Hello, Pamela Stokes here, and we've got another episode. What I'd like to talk about today is how stress affects our brain. I'll begin by reminding you that things you probably know already, that stress can affect your body in many different ways. It can affect your immune system, it can affect your nervous system, it can affect your digestion and your hormones, just to name a few. And when we have stress in our everyday life, it can compound. And that's what we're going to be mostly focusing on today, is that compounded stress. These effects on our body can affect how we are behaving in our everyday life, and they can affect things because of the hormonal effects. We can have weight gain, and because of the nervous system effects, we can have irritability and insomnia. And if this sounds like you or someone you know, it's not abnormal. It's the result of the stress in your life. What I would like to talk about today is a different aspect of stress and some new discoveries that are being made in science right now. Before we go into the new stuff, I'd like to just go over a little bit about what we already know. There's a kind of stress that is actually labeled eustress, E-U, and then stress, eustress. And this is what we would refer to as good stress. This is the kind of stress that would motivate you when you're taking a test, or if you have to accomplish something and you need that little boost. And it does provide that for us, which is great. The idea is that, though, we would experience that, accomplish it, finish the test, and then be able to get back into our regular balanced state. So that's positive stress, eustress, also called. The kind that I'd like to focus on a little bit more today is distress, or just what people usually call stress. We have a lot of it right now. I mean, we are in a pandemic, which is an unprecedented experience for all of us, and with an indeterminate amount of time that we'll be in lockdown and mask wearing and all of that. So that is a stress. That isn't a positive stress. It's not necessarily helping us accomplish something. And the other aspect of life that's happening in the U.S. right now is we are electing a new president, which is putting a lot of stress on many people because of the differences between viewpoints and opinions. So this can also cause stress. And then you add into that things that are your everyday experiences, like deadlines for work and getting the kids fed and just finishing your laundry and things like that. Those are things that are adding into our overall picture of stress. Stress can be in many different aspects of our life. It can be emotional, it can be mental, it can be physical, or environmental. So there's all of these different things that can be going on in our lives, and all of this adds up. One of the things that is very intriguing to me is there was a study done by Kaiser back in 1995. For a couple of years, they collected information. They collected a survey from adult patients that were experiencing illnesses, and they were asking them if they had had any adverse childhood experiences. And they call this the ACE study or ACE survey. And a lot of times people just refer to it as ACEs. So if you have a higher score on the ACEs, then there's more likelihood that you will have an adult illness, such as obesity, diabetes, and heart disease. Now, these are things that are very commonly occurring, especially in the U.S. And now, finally, almost 20 years later, after the study was completed, the information is getting to the physicians that need to know that this is something to screen for, something to look for. And I'll probably be doing another podcast specifically about ACEs, and so we'll go over all of the things that are asked in that. But in California, where I live, fortunately, there is a program called ACEs Aware, and put by the Office of the Surgeon General, and it is allowing physicians and other people in healthcare to know how to screen for people and to see if these are existing in their past. So these are things that would happen in childhood that affect the health outcome of an adult. It's very interesting that something that happened so long ago could possibly lead to adult illness, but nevertheless, that's what the study found out. And finally, it takes, many, many years for this information to become mainstream. And this is something that I hope is more available to all of us. So I was curious if you have this in your state or your country where you live, a program like this where they're getting the information out about this study so that people know that there's a relationship between things that happened when they were children and their health as adults. So if you do know anything about that, please send me an email. The email address is podcast@moveintoresilience.com. So you can just send me an email and just let me know if you have heard of the ACE study, the survey, and if it is something that is being talked about where you live. I'm very curious about that. Now, moving forward, I'd like to talk about something that is brand new. This is information that basically 2 years ago was discovered in laboratories, and a book has recently been published called The Angel and the Assassin by Donna Jackson Nakazawa, and I'll have links to that in the show notes. This book was basically her self-discovery, trying to figure out what is going on with her body. She's got something that the doctors are kind of like, well, your nerves are just falling to pieces. The myelin sheaths around the nerves are being broken down, and there's really nothing we can do about it. And she just was thinking, no, I don't think that that's okay, and I want to find out what there is going on in the scientific community. She's a science journalist, and so this was appropriate for her to be investigating, but it also applied to herself. So it was eye-opening information. And what she brings up in the book is a part of the brain. These are very small cells called microglial cells, and they are seen to be the cleaner-uppers of brain, dead brain cells and things. That we've known about this for about 15 years, that this is what they do, microglial cells do. So this isn't the new information, this is kind of new. And the microglial cells will let their tendrils out, and so they have all these long tendrils on the cell body that reach out and check on the neurons to see, is everything okay? Are you guys doing all right? Just checking in. And so they're constantly moving these little tendrils around, very active. When they find that there's a problem, when they find that there's a neuron that maybe has died, they will change their form. They'll pull their tendrils in. It's kind of cool. They'll pull their tendrils in and become more amoeba-like, and then they will engulf that piece of the neuron and eat it up. And it's very familiar to the scientific community that this is a behavior of something that we also have in our body called macrophages, which are some of the white blood cells that we have. So these are very similar in structure and function. And so it was assumed that this microglial cell is like the immune cell of the brain. So this function of cleaning up the old dead brain cells is well known. And another function that they serve is to prune back neurons. When we're infants, when we're born, we have way more neurons than we need. And over time, those neurons are pruned back. They're destroyed, basically, and eaten up by these microglial cells. That's another one of their functions. It's kind of like a tree. If you want it to produce fruit, you want to prune away all the extra branches that would be taking energy that could go into making fruit. And by pruning it back, you're making a healthier tree, a stronger tree. So analogy-wise, that's similar to what's happening in our brain all through infancy and childhood and adolescence. It's a normal process. Now, this pruning back can also take place if we are, as adults, doing something repetitively. And we don't need so many of those neuronal connections. So the pruning back can happen then too, a little bit of that pruning back. So these scientists were wondering, and I'm happy to say they were female scientists. It makes me happy because I studied biology and I was in the field of science, and I think it's great that more women are doing research like this. So anyway, just little ring the bell for female scientists. But what they were looking for was to find out is it possible that the microglial cells functioning as these pruning back, in that pruning back function, perhaps it would get stuck in the on position. So this pruning back could continue throughout the lifetime of the person. And that was their big question. And it turns out that indeed this does happen, and it can happen. So what does that mean? That means that a normal, healthy neuron that is needed might be attacked and destroyed by a microglial cell because of this getting sort of stuck in the on position. Big news. This is big news. This is brand new. They have just discovered this in the last couple of years. What this means for us then is that there's the possibility that our brain is getting, unfortunately, destroyed by our own microglial cells. And so the question was, why is this happening and what's causing this to happen? They have done enough studying, and a few other labs got involved to study this. And what they determined was it's like an immune response gone haywire. So just like in our body, if the immune response, basically if we've got too much stress, and the reason why I brought up ACEs is because we're seeing that this kind of stress, this what they call toxic stress in the ACEs study, where it's childhood stress that is accumulated over a lifetime and never abated and not really worked on, and just over time, it starts to decay the body. And we can also get into conditions that are autoimmune. So we can have things like fibromyalgia and MS and lupus and things like that. When they figured out that these microglial cells could get stuck on, so that's the immune response getting stuck on and basically kind of deteriorating our body when it's not really supposed to be doing that. It's supposed to be taking care of the cells. Instead, it starts destroying the cells. The same thing can happen in our brain. So we see oftentimes someone who has, let's say, lupus also have a mental disorder like anxiety or depression. And the conclusion is you can have an autoimmune problem, syndrome, illness, or you could have a brain illness like depression or OCD or ADD, or you could have both. And so this is what is so interesting and very new, and it's a whole different way of looking at brain health and how it relates to our immune response and how we respond to stress. It's big news. So I think it's a good time now to do a little activity so that we can kind of let that settle in our bodies. So let's go ahead and do a sigh of relief together. It goes like this. Through your nose, take in a small amount of air, inhale, and then another inhale, a bit larger, and then with your mouth closed, you're making a sigh. And then if you can imagine your breath going down through your pelvis and out your legs on that exhale. And then notice how you feel. Let's try that again. We're going to take a small inhale through the nose, a larger one, and then imagining the breath moving down through the pelvis and out the legs. And then notice how you feel. Great. So I'm bringing up this information not to frighten you, not to stress you out, but more to educate you so that you understand how the body and the brain can work and the important effect of and profound effect of stress on our body's health, and now also we understand it's affecting our brain. So the title of the book, Angel and Assassin, comes from the fact that these microglial cells take care of neurons. They help support them, bringing in nutrients and moving things around, taking away debris, but they also can be assassins and seek out healthy neurons and kill them and eat them. So that's where the title comes from. Another thing they're looking at, that the scientists are looking at that are studying these cells, is one of the pieces that the microglial cells takes up are beta amyloid plaques, which are in the brain that can accumulate and cause Alzheimer's. So there is a possible correlation between the overactive immune response or the stress response in the body and the lack of taking these plaques out. The microglial cells are like not doing it. They're just leaving them behind. So that's another possible outcome of this. And so we're seeing that there is a possible correlation between the autoimmune syndromes and mental health, or conversely, there may be a mental health issue or a dementia that can come about that relates to this stress response being on active too long. And that is causing the microglial cells to do too much. They're too active and taking the neurons away. And especially in the hippocampus, they have found that this is where we form memories, or the ability to form memories. And so if you're destroying those cells, there is the potential for not keeping your memory. So we have seen a huge increase in early onset dementia or early onset Alzheimer's. And we've also seen a really big increase in the amount of anxiety and depression. Younger and younger children are being diagnosed with this. And they were surmising that it wasn't just because we have better ways of detecting these things. They're thinking that it's probably because we're not handling our stress well. Okay, that's the big news. I would like for you to share this news with people that you know, and maybe even on social media. The information needs to get out to the regular people so that there are more ways of just educating us on the importance of de-stressing. I can't stress enough that we should get rid of our stress. And historically, when something new like this comes out, basically changing the paradigm that we thought was true, it takes years, decades, for the information to get from the published scientific journals where they've replicated the experiments and they know that this is happening, to the doctor's office where these pieces can kind of come together and help people to get better, or at least understand why they're not well. So it is my hope that together as a community, we can get this information pushed a little bit faster than decades. I'd rather not wait decades. So me personally, what can I do? Well, I can at least inform you, but also I can show you some of the things that will help reduce this stress. And that is my passion in life, is to help people to know ways that they can help themselves to feel better and to feel calm and to come into a nice regulated state. This process that we're using, that we're involving, is the process of neuroplasticity. Neuroplasticity, by definition, is the ability for our brain to create and reorganize synaptic connections because of learning something, experiencing something, or if there's an injury. And in our work, what you'll be learning here in this show are things that are using that process of neuroplasticity to change the way your brain is functioning, so that we're making new pathways, we're making new ways of moving and of feeling, sensing in our body ease and comfort. And when we have ease and comfort, that is the signal that our nervous system needs to know that it can function optimally, because it's saying all is well. When there's ease and comfort and flow in your body, that is a signal to the brain that everything's okay and things can happen as they normally should. I will be doing a podcast episode on neuroplasticity and getting a little bit more into that. So if you want to be alerted, you can subscribe, and then you'll get a notification when that episode comes out. And I have to say, side note, I am of the age that it still amazes me that we can do this kind of stuff, the technological stuff. So anyway, just really cool. So what I'd like to do today, another motion that is going to involve just simply breathing, noticing, and sensing in your body, that has been shown by a group called the HeartMath Institute, and I'll put this in the show notes as well. They've been studying this for 30 years. There's scientific proof. They've got EEGs and blood counts and all different things. They're looking at immune response and so forth. That this is a very effective way of turning off the stress response, getting the body back into homeostasis. And they have shown that it creates what's called coherence. Coherence is when things are moving in unison. So you can imagine the electrical output from the heart having a certain wavelength, there's certain frequency, and the heart has that frequency, and then the brain has its own frequency. And when we're working in this way, and we'll be doing it in a moment, when we're working in this way, we can get these two parts of our body to come into harmony. And I know that sounds kind of woo-woo, but it's actually not. It's coherence. It's when the waves are lining up together. And what does coherence do? Ta-da! It turns off the trauma response. It turns off the stress response. It tells your cells everything's okay, function normally, function optimally. So we're healthy. And what's really great about this activity is it will last, the effects will last for hours. I think they measured it to be 6 hours. So you don't have to do it all the time. You can do it a couple times a day and you're good. So I could probably just maybe stop this podcast altogether and just show you that one and you'd be good for the rest of your life. But in any case, I like to add more. I think the more the better as far as these activities go. These are good for in the moment use as well as long-term, building long-term resilience. So this is called Heart Coherence. I like to call it Heart-Brain Coherence. And we're just going to do this together. So find yourself sitting. You could also stand, but I think sitting is nice because you're a little bit more relaxed probably. And what you'll be doing is following along with what I say and just staying in with this. So it's kind of like a meditation, and then we'll finish up at the end. Please join in. Begin by sitting with your feet flat on the floor and keeping your legs and arms uncrossed. And then just notice your breathing, keeping your spine long. And then I'd like you to slow your breathing down to 6 seconds for the inhale and 6 seconds for the exhale. And I'd like you to imagine your heart area, the heart in the center of your chest. You may want to bring your hands to your chest, to your heart area, just to feel it in there a little bit. And imagine seeing the front of the heart and the back of the heart and the sides of the heart. There's a 3-dimensional object in there. And I'd like you to, with this 6 seconds in, 6 seconds out, I'd like you to imagine the breath is moving in and out of the heart. So you're breathing in, 6 seconds in through the heart, and 6 seconds out through the heart. And think of the whole heart breathing. 6 seconds in and 6 seconds out. And you can close your eyes if that's comfortable for you. And if it's not, you can turn your eyes downward to look at the floor, just to gaze softly at the floor. Breathing in 6 seconds and out 6 seconds through your whole heart. And now I'd like you to add in an elevated emotion. The way that I like to do this is to imagine my pet's face. You could also imagine a scene in nature or a person, something that makes you feel wonder, happiness, joy, awe, something pleasant, a pleasant emotion. And allow the sensations in your body to happen. And keep breathing that 6 seconds in, 6 seconds out through your heart. Keeping that elevated emotion present. Breathing gently, 6 seconds in, 6 seconds out. Through your heart. Great. And now we'll come back to regular breathing and allow yourself to come back into the room where you are. Allow your eyes to open gently. And with a soft gaze, we'll do a little orienting. So let your eyes wander and your head follows where your eyes lead. And then let your eyes wander another place and let your head follow. Eyes wander again, your head follows. And then you can just come back into the room where you are. And just breathing regularly. And then notice how you feel. That's what we have covered today. We've talked about the ACEs study. We've talked about good stress. We've talked about toxic stress. We've talked about the microglial cells and the book Angel and Assassin. All of these pieces will be in the show notes. I thank you so much for being here. I hope you'll share this information, subscribe, and download so that you can listen again or share it with friends. This information really, it's important to me that it gets out so that people who are struggling with health issues and without any answers can finally get some clarity about what is possibly going on with their body. And by doing the techniques that you're learning here in this podcast, you will be able to turn off that stress response. You will be able to tell those microglial cells to be angels again and to have optimal health. So thank you again for joining me for Move into Resilience. I'm Pamela Stokes. Take it easy.